I welcome you to today's episode of our podcast series, Autonomous Weapon Systems and Human Control. In this episode, we will look at the predictability of autonomous systems. Our guest today is Serhiy Kandul. A warm welcome to you.
Hello.
Serhiy Kandul is a postdoc at the Institute of Biomedical Ethics and History of Medicine at the University of Zurich. In his current research, he's trying to understand how people perceive algorithmic decisions. Mr. Kandul, in today's episode, we look at the predictability of autonomous systems. You have already researched and published on this topic. Could you briefly outline the focus and main areas of your scientific work?
I joined the University of Zurich, the Digital Society Initiative in 2020. And as a postdoc, now I'm part of two SNF projects under the National Research Program Digital Transformation. So the first project deals with social acceptability of AI, fairness of AI. And in the second project, we look at the meaningful human control of AI. So my role in both of these projects, my background is behavioral and experimental economics. So I provide empirical support, we test how people perceive AI in various applications and how they engage with AI systems and what is required to make this human-AI collaboration effective.
In a laboratory experiment with test subjects, you compared the predictability of the actions of an AI system and a human operator. The result of the experiment was that the participants were able to predict the actions of the human operator slightly better than those of the AI system. Could you go more into detail about the experiment and the way it was conducted?
So for this experiment, we invited more than 100 participants at the ETH lab, and we have confronted them with a real effort task. The task was to navigate and land the spaceship on the computer screen safely by using the keyboard. So the task required attention and some experience with gaming. So it was a challenging task for humans to perform. So that's why we thought it was a good task when AI can actually outperform humans. But the performance, it was not the key focus of the task. The task was, the idea of the experiment was to see whether if I observe the AI landing the spaceship or a human operator landing the spaceship, to what extent people are able to predict whether it would be a successful or a failed landing. So in that experiment, we did not require that people would understand deeply what would be the next move of the AI or human operator. And at this basic level, we already noticed that there is a gap between AI and human predictability. So people can understand, human patterns better than AI because AI does it differently from humans.
From your point of view, what are the key takeaways and possible impacts of this moon landing experiment?
I think the first takeaway message is we should not take for granted AI predictability, that people can, without being able to predict AI, even talking about exercising human control is not possible. So in every context, we would first have to establish that a certain level of AI predictability is warranted. And the second message is, so in contexts when we do observe different behavioral patterns from AI and humans, so these are the contexts where these discrepancies between AI and human predictability are likely to emerge.
What measures could be implemented to predict the actions of autonomous systems more reliable and accurate in the future? Or in other words, how can we close the gap between AI and human predictability?
So a few measures or a few attempts have been suggested. One of them is to increase AI explainability, which is conceptually a very challenging task, but to understand, how in that context that would mean, for example, that people would understand how AI navigates the object, how it calculates the velocity, the trajectory, the speed, to understand the inner mechanics of these. And then if you understand these, then when you observe a particular trial landing, you would be able to predict whether it would be a success or a failure. But at the minimum level, if this is difficult to achieve, so what we have tried to do, we have tried to provide people with so-called confidence scores. These are self-estimated probabilities of success. So in real time, the participants were shown on the screen like a number from 0 to 100. And higher numbers means, okay, there's a higher probability of successful landings. What we have seen that even, provision of these information did not really close this human AI predictability gap. Because we have seen that it's not enough just to implement these scores. Participants, they also have to interact with the scores to understand how this is computed and also trust the scores. So we have seen from some of their answers that they would say, well, I have largely ignored the scores because I was unsure what does it tell me, or I have seen that the trajectory was different from what the score was showing me. So I think that's another challenge, is to increase understanding of the information that we are trying to provide to help people.
Finally, I would like to know from you what level of predictability should be in place so that an human operator can exercise effective control over an autonomous system.
It is tempting to say that the natural benchmark should be at least the human level predictability. So operators, they should be able to predict AI as they can predict human operators. But we have seen that sometimes it reduces the performance of AI systems, so there are all these possible trade-offs. And I would say it depends on the context. In the high-stake context, we have seen that people demand, they demand higher level of AI predictability. For example, if it in security context, for example. But in other contexts, like, for example, fake news detection, when the stakes are not very high, they say, well, I don't even need to understand, how the AI does it works. But in this context of autonomous systems in security, we have seen in the surveys that people would demand, even higher predictability than a human predictability.
Mr. Kandul, we have already reached the end of the interview. I would like to thank you very much for the conversation and for sharing your insights with us. At this point, I also thank our audience for listening.